Okay, so let's take a look at linear and continuous. So first of all, let's take a table of values, x, y. And on the x, let's say -4, -2, 0, 4, 8. And on the right-hand side, let's say 0, 3, 6, 12, 18. So this is linear if you put it on a graph and it makes a line, obviously. Or figure out what the x goes up by, +2. It's called delta x or triangle x. And then it goes up +2 again. Then it goes up +4, interesting. Then it goes +8, interesting. Okay, the right-hand side goes up by 3, and then up by 3, and then up by 6, and then up by 6. So how is that linear just by looking at the table without putting it on the graph? Well, we know that the fraction of whatever the y changes by over the fraction of whatever the x changes by, represented by triangle, change in. If those fractions are the same, then it's linear. So the y is going up by 3, circle it. When the x is going up by 2, then the y is going up by 6 when the x is going up by 4. Notice exactly where I circled. That below didn't go up by 4. I'm going to put an arrow to it. I'm going to erase the 8 and put a 4 back. I'm going to put that in red so we remember that that's new. I'm going to put it in blue so remember it's new. Excuse me. That will happen from time to time. Sorry. So again, now in blue, they're going up by 6 and then going up by 4, and that pattern continues. And that equals 6 over 4. And these fractions are the same, so check mark, linear. The root word line with an A-E-A-R, excuse me, linear. So outside of that, again, if you have a graph and it's a straight line, it's linear. If it's not a straight line, it's not linear. Like, come on, is it a line or not? Now, discrete. So the question is, we have some points on the graph. Those are linear because they would make a line. And then points that aren't linear because they wouldn't make a line. And we call these discrete, where you cannot connect the lines. For example, if you're putting pennies on a scale and you add a penny, it goes up by a certain weight. Then you put another penny on, it goes up by a certain weight. You can't connect the lines. But if you're doing a running race, you can graph every single point, so that would be continuous. So we have discrete, the points, and continuous. Ones that go forever, can continue, can connect the points. Discrete, cannot. So we have all sorts of English instructions about when they're continuous and discrete. Things that are not linear, just make a table of values or draw a graph and figure out if they make a line or not. Not linear. So some things that are linear are like y equals 3x plus 1. Or 2y plus 3x minus 4 equals 0. We're going to graph those in the next section and see how they're linear. Or just make a table of values and learn how to graph stuff. Things that are non-linear, like y equals x squared. We're going to work on that next year. Y squared plus x squared equals 1. A different shape that we're going to learn in grade 12. Y equals x cubed. 1 second. Y equals x cubed minus 2x plus 4, not linear. We're typically going to have exponents of 1 for the variables. So off to the left, usually if we have two variables with an exponent of 1, then it's linear. And if you find something that's an exponent of not 1, it's just not linear. And there's so many examples of things that are not linear. I can't list them all. Just know what's linear and then recognize that if it doesn't look like that, it's not. So that's linear, linear, nonlinear, continuous, and discrete.